In 1935, Australian scientists made a decision that would become one of the most catastrophic ecological mistakes in human history. And the weapon they chose was a warty, 6-inch-long amphibian with enough poison to kill a grown crocodile. Today, over 200 million cane toads march across Australia like a toxic army, spreading at a rate of 40 kilometers per year, killing everything that tries to eat them, and there's virtually no way to stop them. Northern quolls have declined by 95% in toad-infested areas. Freshwater crocodiles wash up dead by the hundreds, and entire populations of native predators are being wiped out by a creature that was supposed to be a hero. Yet in 1935, this wasn't an invasion, but was a carefully planned solution to save Australia's struggling sugar industry from total collapse. Then everything went wrong, and what happened next turned a simple agricultural experiment into an ecological nightmare that's still spreading today, almost 90 years later. So how did 102 toads become 200 million? Why can't Australia stop them? And could this toxic plague ever be reversed? Let's find out together. Right now, you're looking at Queensland's sugarcane fields, stretching across millions of acres of Australia's northeastern coast. And in the 1930s, this region was facing disaster. The cane beetle, a gray-brown insect barely an inch long, was devouring sugarcane crops at an alarming rate, and these beetles, both the grayback and the French's varieties, would feast on the roots and stems of young cane plants, causing crop losses of up to 30% in some regions. Farmers were desperate because Australia's sugar industry employed over 30,000 people and generated millions of pounds in export revenue. But the beetles were winning, and chemical pesticides of the era were expensive, ineffective, and often toxic to workers. The Bureau of Sugar Experiment Stations, a government-funded research organization, was tasked with finding a solution, and in 1932, they heard about a miracle story from Hawaii. Hawaiian sugar plantations had faced a similar beetle problem decades earlier, but they'd found an unlikely hero, the cane toad, known scientifically as Rhinella marina, a large amphibian native to Central and South America. According to reports, these toads had been introduced to Hawaii in 1932. Farmers claimed they were controlling beetle populations by eating adult beetles in the fields at night. And the solution seemed perfect because toads cost nothing to maintain, required no special equipment, and reproduced naturally. Australian agricultural scientist Reginald Montgomery traveled to Hawaii to investigate. And what he saw convinced him completely because he watched toads hopping through cane fields, seemingly devouring pests, and returned to Australia with glowing recommendations. In June 1935, the decision was made, and 102 cane toads were imported from Hawaii to Gordonvale, just south of Cairns in Queensland. The toads were placed in captivity to breed, and by March 1936, their numbers had exploded to over 62,000 individuals, which were then distributed to sugarcane farmers across Queensland. The plan was simple: release the toads into the fields, let them eat the beetles, and watch crop yields soar. But what scientists didn't understand was that they were about to unleash an ecological weapon with no natural enemies, no biological controls, and an insatiable appetite for survival. And here's the terrifying part. Cane toads possess one of nature's most potent defensive weapons, bufotoxin, a milky white poison secreted from glands on their shoulders. This toxin is so powerful that a single toad contains enough poison to kill animals as large as freshwater crocodiles. And when a predator bites a cane toad, the toxin causes rapid, irregular heartbeat, excessive salivation, convulsions, and death within 15 to 30 minutes. There is no antidote. Australia's native predators, which had evolved over millions of years without encountering toxic toads, had no idea what they were dealing with, and every snake, lizard, bird, and mammal that tried to eat a cane toad died. What the worst part? The toads didn't even do what they were supposed to do because cane beetles live high in the sugar cane stalks. But cane toads are terrestrial ground dwellers that rarely climb. The two species barely interacted at all. By the 1940s, scientists began to realize their mistake, but by then, it was far too late because the toads were breeding at a staggering rate. A single female cane toad can lay between 8,000 and 30,000 eggs in a single clutch twice per year. And unlike native Australian frogs, which require specific breeding conditions, cane toads breed in almost any standing water, ponds, puddles, swimming pools, even drainage ditches. Their tadpoles are toxic too, making them unpalatable to fish and aquatic predators, which gave them an enormous survival advantage, and juvenile toads mature in just 6 months, meaning the population could double multiple times per year under ideal conditions. By 1950, cane toads had spread across most of Queensland, and by the 1970s, they'd crossed into the Northern Territory. And by the 2000s, they'd reached Western Australia, advancing westward at approximately 40 to 60 kilometers per year. Today, cane toads occupy over 1.2 million square kilometers of Australia, an area roughly the size of France and Spain combined, and their population is estimated at 200 million individuals and still growing. Let that sink in. 102 toads became 200 million in less than 90 years, and they're not slowing down. When a toxic invasive species enters an ecosystem, the consequences cascade through every level of the food web. And in Australia, those consequences have been nothing short of catastrophic. The northern quoll, a small carnivorous marsupial found only in Australia, has been devastated because these cat-sized predators naturally hunt small prey at night. And when they encounter cane toads, they instinctively attack and bite them. Studies show that northern quoll populations decline by 75% to 95% within 2 years of cane toad arrival. And in some regions, entire populations have been completely extirpated, meaning locally extinct. The quolls simply couldn't adapt fast enough because evolution operates over thousands of generations, not decades. Freshwater crocodiles, ancient reptiles that survived the extinction of the dinosaurs, are also dying in massive numbers, because unlike their aggressive saltwater cousins, freshwater crocodiles are smaller and eat prey like frogs and small mammals. When cane toads invade a waterway, young freshwater crocodiles eat them and die, and in some areas of the Northern Territory, researchers found mortality rates exceeding 70% among juvenile crocodiles. Entire river systems that once thrived with crocodile populations are now toad-dominated death zones. But it doesn't stop there, because goannas, large monitor lizards that are apex predators in many Australian ecosystems, also die from eating toads. Yellow-spotted monitors, lace monitors, and sand monitors have all experienced massive population crashes in toad-affected regions. Even snakes aren't safe, and the red-bellied black snake is one of Australia's most iconic reptiles. It's declined significantly because these snakes naturally prey on frogs. A cane toad looks like a meal until it delivers a fatal dose of bufotoxin. Birds of prey like the black kite and the tawny frogmouth have also been documented dying from toad poisoning, and dingoes. Australia's native wild dogs occasionally die from eating toads, though they seem to learn avoidance behavior faster than other predators. The ecological impact ripples outward because when top predators die, prey species populations explode, vegetation is overgrazed, insect balances shift, and entire ecosystems destabilize. Scientists estimate that cane toads have contributed to the decline or local extinction of dozens of native species, and the true number may never be known because many impacts occur in remote areas where wildlife monitoring is limited. And here's something truly disturbing. Cane toads are also evolving to become better invaders, because at the invasion front, the leading edge of the toad population, researchers discovered that toads have longer legs and greater endurance than toads in established populations. This means that the fastest, strongest toads spread ahead, breed with each other, and produce even faster offspring, creating a biological arms race where evolution is making the invasion worse. In 2006, groundbreaking research by Professor Rick Shine at the University of Sydney confirmed this because toads at the invasion front could travel 5 times farther per night than toads in older populations. Natural selection was favoring invasion traits, and the toads were becoming unstoppable. Faced with an ecological disaster of unprecedented scale, Australian authorities realized traditional solutions wouldn't work because you couldn't poison cane toads without poisoning native frogs. You can't trap them effectively because they're too numerous and too widespread in biological control. Introducing a predator or disease was out of the question after the cane toad disaster itself proved how badly that could go wrong. So Australia did something different. They turned to science, innovation, and community action. In 2009, researchers at the University of Sydney developed a breakthrough strategy called toad smart training, where native predators like northern quolls are exposed to small, non-lethal, juvenile cane toads. The toads are too small to deliver a fatal dose, but they're toxic enough to make the predators sick, and the quolls learn to associate toads with nausea and avoid them in the future. Early trials showed promise because trained quolls survived in toad-infested areas at rates 60% higher than untrained populations, and in 2020, researchers began training wild quoll populations before toad arrival, essentially teaching entire communities to avoid the invaders. It's not a solution, but it's a lifeline for some species. Then there's the community response, because across northern Australia, thousands of volunteers participate in toad-busting events where groups gather at night during the wet season, when toads are most active, to manually capture and euthanize them. In some regions, organized toad hunts have removed over 100,000 toads in a single season. And while that sounds impressive, remember that 100,000 toads is just 0.05% of the total population. It's a drop in the ocean, but locals refuse to give up. Scientists have also developed innovative traps called tadpole traps that exploit cane toad biology, because cane toad tadpoles are cannibalistic and are attracted to chemical signals from toad eggs. Researchers use this behavior to lure tadpoles into traps baited with toad egg extract. And in controlled trials, these traps removed up to 80% of tadpoles from test ponds. The strategy is called targeted tadpole trapping, and it's being rolled out across key breeding sites in the Northern Territory and Western Australia. Then there's the genetic approach, where scientists at CSIRO and the University of Adelaide are exploring gene drive technology, a cutting-edge method where modified genes spread through a population, potentially making toads less fertile or more vulnerable to disease. It's controversial, highly experimental, and years away from implementation. But desperate times call for bold science. Australia has also invested millions in public education campaigns warning people not to touch cane toads, to keep pets away from them, and to report sightings in new areas. Early detection is critical because stopping a new invasion front is far easier than controlling an established population. Now, after nearly 90 years of invasion, something unexpected is happening. Some native species are fighting back. In 2014, researchers discovered that some populations of red-bellied black snakes had evolved smaller heads, which prevent them from eating large, lethal toads, while still allowing them to eat smaller native frogs. Evolution in action, happening in real time. Similarly, some meat ants and water rats have learned to flip cane toads onto their backs and eat the non-toxic belly flesh while avoiding the poisonous glands. And black kites and crows have been observed doing the same. Nature is adapting, slowly but surely, and while it's not enough to reverse the invasion, it's proof that ecosystems can find ways to coexist with invaders over time. But the clock is ticking because cane toads continue to spread. And Western Australia's unique ecosystems, including the Kimberley region, are now under threat. Scientists estimate that without intervention, toads could reach Australia's western coast by 2030. And once they're established across the entire continent, control becomes exponentially harder. Here's the part nobody wants to hear. The cane toad invasion isn't just an Australian problem, but is a warning to the entire world. Across the globe, invasive species cause an estimated $423 billion in economic damage annually. And ecosystems from the Caribbean to Southeast Asia face similar threats from introduced species that seemed harmless at first. The cane toad disaster happened because scientists didn't understand the complexity of ecosystems. And they assumed that what worked in Hawaii would work in Australia. And they didn't consider the unintended consequences of introducing a species with no natural enemies. If there's one lesson from Australia's cane toad crisis, it's this. Once an invasive species establishes itself, eradication becomes nearly impossible, and prevention is the only true solution. Countries like New Zealand have learned this lesson and now have some of the strictest biosecurity laws on Earth. And in every package, every suitcase, every shipping container is inspected, because keeping invasive species out is infinitely easier than removing them once they're established. Australia learned the hard way, and today it spends over $100 million annually on biosecurity to prevent the next cane toad disaster. So, can Australia ever be free of cane toads? The honest answer is no, because with 200 million toads spread across 1.2 million square kilometers, complete eradication is impossible with current technology. But management is possible, Because with continued research, community involvement, and innovative science, Australia can slow the spread, protect vulnerable species, and give ecosystems time to adapt. The cane toad will never disappear, but perhaps it doesn't have to, because maybe over generations, Australia's wildlife will evolve resistance. And maybe humans will develop better tools, better strategies, better science. It's not the happy ending we want, but it's the reality we face, and every toad removed, every quail trained. Every tadpole trapped is a small victory in a war that will last generations. And maybe the greatest legacy of the cane toad disaster is into the toads themselves, but the lesson they teach us, that nature is complex, unpredictable, and unforgiving of our arrogance. And that every action we take in the natural world carries consequences we can't always foresee. The 102 toads released in 1935 were meant to save Australia's sugar industry, but instead, they changed the continent forever, and that's a mistake humanity can never afford to repeat. If this story amazed you, you had no idea that 102 toads could become 200 million, then share it. Talk about it, and remember it the next time someone suggests introducing a new species to fix an ecosystem problem. Let's make sure the cane toad disaster remains a cautionary tale, not a blueprint. What do you think? Could Australia ever truly control the cane toad population? Or is this a battle that's already lost? Share your thoughts in the comments below, and don't forget to like, subscribe, and hit the notification bell so you never miss another wild and unbelievable animal tale. Because when it comes to nature's greatest disasters, the truth is always stranger than fiction. Thanks for watching Vet Tips, and next time, we'll explore another incredible ecological story that will leave you speechless. Stay curious, stay wild.